In this series of videos, we are going to talk about design patterns, and we're going to talk about a couple of them, but I'm going to start with just a little bit of an overview or an introduction about what design patterns are. So this series of videos is far from being um, a complete instructional set or curriculum related to design patterns. You can actually teach an entire course about design patterns. And actually, a lot of design patterns are covered in different software engineering courses or other similar courses. So, this is not going to be an exclusive or exhaustive discussion about design patterns, but we are going to just cover a couple of them. And then I encourage you to look into others on your own. And also, it's good if you just kind of are familiar with a couple of design patterns. It makes it easier to learn new ones because you kind of get into to understanding the whole idea of what a design pattern is. So this idea of design patterns were first initiated by a couple of authors that are referred to as the Gang of Four, or the GOF, in this book, Design Patterns, Elements of Reusable Object-Oriented Software. So you're welcome to check that out. This is kind of the book about design patterns. And essentially what a design pattern is that it's just an approach that allows us to reuse ideas at the design level. So we already know that it's good to reuse code, right? If we have a couple of statements that we're repeating multiple times, we might put those statements inside a method and then invoke that method multiple times rather than repeating the code, right? We also know that inheritance is another way that we reuse code. So we know that reusing code is good, right? If there's code out there that exists to do what we want to do, we want to reuse it rather than write new code, right? So we already know that is good. But what design patterns are they're a way to allow us to reuse things at kind of a bigger level, kind of one level up. We're essentially reusing an approach to a solution. So we're not reusing a particular bit of code, but we're taking a particular approach and reusing it. So we're saying, hey, this is a way to solve a problem. This is an approach to a problem. This is the design of a solution. And we can apply that solution to many different problems and many different programs. So that's what a design pattern is. It's an approach to a solution that we can reuse across problems. Design patterns, they allow us to have a shared vocabulary. So if there's a particular way of approaching a problem and you're on a team of people that are working on this problem, if you all know about certain design patterns, you can say, hey, I think this particular pattern would be a good way to solve the problem. And then you can use that shared vocabulary to talk about, is it the right solution or not, and kind of have a discussion about it. So they provide us with this shared vocabulary, and they also represent best practices. So these design patterns are things that have been studied, that approaches to different problems and different solutions that are shown to work really well. So it allows us to kind of collect those ideas into a set of best practices and then all have a shared vocabulary to talk about them. Using design patterns help us build programs that are reusable, extensible, and maintainable. So these are all things we want in our code, right? And I would actually also add flexible to that list as well. So we want to write programs that we can easily reuse, that we can extend so that we know that we're always building onto things that we've written in the past. Any piece of software you have that is useful probably goes through updates pretty frequently. So that's that software being extended, and then also maintained, right? So we want to be able to go in there and fix things and maintain the software, keep it up to date. And using design patterns helps us to do all of these things. That Gang of Four based their original design patterns on two principles. One principle is program to the interface, not to an implementation. And we've talked a little bit about that in previous videos. Essentially, what this is describing is this idea that we want to kind of keep our references and our variables and our solutions as general as possible. So for example, if we know that we need to use a list in order to solve a problem, well, let's declare our variable as type list. And that will allow us to program our solution to the interface of a list. But we can then initialize or instantiate that list as type array list or linked list or lots of different types of classes that implement a list. But we don't make that the declared type. We don't declare and say, well, I'm going to write my solution using an array list, unless I really need the specific functionality of an array list. If the only functionality I need is a list, let me just write the solution for a list, and then I can go ahead and I can initialize as array list or linked list or whatever, but I'm only relying on the functionality of a list. So the idea is to kind of think about what you need in your solution and program only to that functionality and kind of keep it at a general level whenever you can. That allows programs to be more reusable and extensible and maintainable. Because to use that same example, let's say we again are writing a solution that involves a list and we declare our variable as type list. We initialize as array list, but then throughout our code, we're just treating it like a list of some unknown type. If later on we want to come back and say, actually, I think a linked list is going to be more efficient for this solution, I can just swap it out in that one initialization statement. The rest of my code is going to work fine. Okay, so programming to the interface, really just defining the functionality we need and only using that functionality, it really allows us to write programs that are more flexible and more maintainable. The other principle is this idea of favoring object composition over inheritance. So I'm not going to go too much into this right now. We'll talk a little bit more about this when we talk about one particular pattern, which is the strategy pattern. But I encourage you to look up object composition a little bit and explore that idea a little bit before we talk about it. This is kind of another big idea that's related to design patterns and related to object-oriented programming in general. And this was one of the kind of the motivating factors for design patterns. So some of the things we're going to be talking about with these design patterns will be a different way of writing code than what you're used to. So a lot of times you might be thinking, well, we just learned, this whole way of approaching problems, and now you're telling me not to do that and to do it differently. So that's a little bit of a yes, kind of. We are going to be doing that. But that's not to say that all the things you've learned up until now are not important. So all of these fundamental foundational principles are still key. This idea about encapsulation, about keeping our data private and protected is still important. The idea about abstraction and, just defining functionality through levels of abstraction and keeping functionality hidden within classes is still important. Inheritance and polymorphism are both still important. So even though you saw that one of the guiding or motivating principles for design pattern is to favor composition over inheritance, that doesn't mean inheritance isn't important. Inheritance and polymorphism are still very important. We need to use them when they're appropriate, and we need to also understand how they work. So all of these ideas are really still important. Think about these as building blocks. We have to learn them first so that we can understand how Java works and how object-oriented programs in general work. But we might now start to do a little bit different things a little bit differently as well. So think about it like, you do have to learn to walk before you can run, right? A toddler needs to learn to walk before they can learn to run. And once they can run, they might think, hey, this is great. Why did I bother learning how to walk? Well, you have to learn how to walk first. And there's also going to be times when walking is more appropriate than running, even though, from a toddler's perspective, running is great and they want to do it all the time. Okay, so we do need to learn all these things. We need to understand them, and we do still want to be able to use all of them, even inheritance, at appropriate times. But now we might also find some situations where we're going to be doing things a little bit differently. So just keep that in mind. I'm going to be showing you some things that are going to be different from how you've written code before, but it doesn't mean you're going to abandon the old ways of writing code or that your time spent learning those old ways is wasted. You need to learn those ways, and you still want to use them sometimes too. But now we're just going to add some more tools to that toolbox and some more advanced ways of looking at code so that you can use those in the appropriate situations.